So for questions about blocks that are being heated, we want to use the heat formula, which is given by Q, or rather delta Q, equals to mc delta theta. This relates the energy that's going in with the temperature rise, and that is controlled by both the mass and the specific heat capacity. The question wants us to find the ratio of mass between x and y. So let's go on to find out how. Now you notice that there's no time dimension in this equation, right? But what we can cleverly do is divide by delta t on both sides. That is allowed. Let's see what happens. So you have delta q over delta t equals to mc delta theta over delta t. Delta Q over delta T is a form of energy over time, and that is actually power. This is the power of the heaters. And what is delta theta over delta T? Delta theta over delta T is actually the gradient of the graph, because it is rise over run. So this is the gradient of the graph. Now this law applies to both block X and block Y. So Px equals to mx c delta theta delta t x. Py equals to my c delta theta over delta t y. Now he said that the power ratings of the two were the same. So we can equate the two. 1 equals to 2. So mx c delta theta over delta t x equals to my c delta theta delta t y. They're made of the same material, so the c's will cancel out. Now I want the ratio of mx to my, so I'm going to bring my down. To make this a subject of the formula, I'm going to move the gradient of x down. We can then extract these gradients from the graph. So for block X, it went from 20 to 60 in the time t. For block Y, it went from 50 to 60 in the time t. So that's 10 over t divided by 40 over t, which gives us 1 over 4. Hence the ratio is 1:4, and hence the answer is